Hi friends, today we will discuss a problem on induction heating. So let us first see the problem. Let's read the problem first and let us understand. Then we can go ahead with the solution of the problem. Determine the efficiency of a high frequency induction furnace which takes 10 minutes. So we will note down the required data given. So time has been given which is equal to 10 minutes to melt 1.815 kg of aluminum. So weight has been given. Let me take W. 1.815 kg of aluminum. The input to the furnace is 5 watt. So let me take power input is equal to 5 watt. And initial temperature is 15 degrees centigrade. So let me take T1 is equal to 15 degrees centigrade. Specific heat of aluminum is 0.212. So specific heat of aluminum is 0.212 and melting point is 660 degrees centigrade. Let me take this as T2. This is 660 degrees centigrade. And latent heat of the fusion of aluminum is 76.8 kg per kilocalorie per kg. So this is the latent heat of aluminum which is equal to 76.8 kilocalorie per kg. Now we need to find out the efficiency of the induction furnace. So efficiency of the induction furnace has to be found out. So simply we know that efficiency is equal to output power by input power. So which is equal to output power divided by input power. So we know input power but we don't know the output power. Now we need to find out output power. So now how to find the output power? So before finding out output power, we need to find the heat required by this induction furnace. So let us start solving it. So how we need to go ahead with the heat required to melt the aluminum and then heat required to rise the temperature of the aluminum. Okay, because we need to melt the aluminum here and the melting point has also been given and the initial temperature is 15 degrees centigrade. So to melt the aluminum we need to heat it up from initial temperature 15 degrees centigrade to melting point 660 degrees centigrade. So this is T1 is 15 degrees centigrade, T2 is 660 degrees centigrade. So with that we need to find the heat required, okay, to melt this much weight of aluminum. And now we need to add both the heats and finally this heat energy we need to compare with the, even we need to take it for 1 hour, okay, and finally we need to go ahead with the solving of the power or getting the output power. Okay, let's move on to these steps, okay, slowly. So heat required to melt aluminum first. So here heat required to melt aluminum is equal to latent heat of fusion of aluminum we have to take here into weight. So this will be equal to 76.8 into what's the weight, 1.815 kg. So this is the weight. So finally this will come around 139.39 kilocalorie. 39 kilocalorie. So this is the heat energy required to melt the aluminum. Now heat energy required to raise the temperature. Heat energy required to raise the temperature up to the melting point is equal to weight of the material and specific heat of the material into change in temperature. So this is the formula. So what is the weight? 1 point. So it is weight equal to 1.815 815 into specific heat is 0.212 into change in temperature is 660 minus 15. Okay, 660 minus 15. So this will come around 248.18 kilocalorie. Now what is the total heat required? So the total heat required is sum of these two, so it will come around 387.57 kilocalorie. So this is the total heat required. Now we need to convert this heat into kilowatt hour, or we can first introduce the time and then go ahead with the kilowatt also. Okay, that's up to you. So first I want to introduce the time here. So this is the power delivered to charge. So first I need to write the total heat required per hour. Required per hour is equal to, I got 387.57, but this is for just 10 minutes. This is for 10 minutes. So I need to divide this one with 10 and multiply with 6. So this will come around 232,325.4 kilocalorie. So this is the heat required per hour. So now we can convert this into, therefore, power delivered to charge or output power. So power delivered to charge is equal to, is the output power. So that is 2325.4 kilocalorie divided by 860. Then I can convert this into kilowatt. 2.704 kilowatt. So this is the output power. Now come back to the previous thing. This is the efficiency, so which is equal to output power 2.704 divided by input power is 5 watt. So divided by 5. Let me take into 100 also, if it is in percentage efficiency. Okay, so which will be equal to 54%. So this is the way in which we need to solve this problem. Okay, first understand the problem properly, then we can solve this problem very easily. Okay, so one more time we can simply recapture this problem. Here we have to find the efficiency of the induction furnace. Okay, efficiency of the induction furnace, which takes only 10 minutes to melt 1.815 kg of aluminum. So we have used some energy to melt this 1.815 kg of aluminum in 10 minutes. Okay, so what is the input actually? So the input has been given, it is 5 watt of input, and initial temperature is 15 degrees centigrade. Specific heat of aluminum is 0.212, melting point is 660 degrees centigrade, and latent heat of fusion of aluminum is 76.8 kilocalorie per kg. So these are the, this is the data they have given to us. So now we need to find the heat energy required to melt the aluminum. So that is the latent heat into weight. Next one is heat required to raise the temperature. That is weight into specific heat into change in temperature. So now we need to add these two heats so that we will get the total heat. Now with this total heat, we can convert the total heat into electrical energy, that is kilowatt hour, or we can convert this heat energy into per hour heat energy, I mean heat required per hour, and then we can directly convert this kilocalorie into kilowatt simply. So we have done both the things are correct only, but we have done in this way. First we have converted into heat energy per hour, and then we have converted into kilowatt. So this is my output power, and input power has also been given, that is 5 watt. So 2.704 divided by 5 into 100 will come around 54%. Okay, so this is the problem. So if you have any doubts in it, please put it in the comment box so that I can answer you within 24 hours. And if you like this video, please like it, and if you want to share this video with your friends and family, please share it, and kindly subscribe to my YouTube channel. Thank you so much.